We are here actually are streaming virtual planetarium. So you know this place in the image now. This is your planetarium where you actually used to come so far before the corona, the uh, the situation that we are, everyone is maybe suffering, so no problem. We still can connect. We can stream the planetarium. We can stream the knowledge. We can actually still educate our people in astronomy and space sciences in the academy. So we hope someday everything will be recovered, soon recovered, inshallah, and we go back to this place, the planetarium, the very beautiful planetarium, the 18 meters in diameter, which can accommodate up to 200 people, and where you can see amazing shows and beautiful journeys throughout the universe. My name is Marwan. I am the director of the planetarium with my colleagues there, Muhammad Hani and Ahmed Salahuddin. We will try together to take you throughout a journey, a very beautiful and amazing journey from Sharjah to the outer space, where we learn a lot about the universe, focusing on two main topics. First one, uh, the Shawwal crescent, the Eid crescent, and in this occasion, I would like just to say Eid Mubarak to everyone. So why tomorrow is the Eid, not today is the Eid. So what is the issue of the crescent? We will just have this in several minutes after we start. The other topic also we are going to focus on is the black holes. That's the main topic of tonight. That is not everything. We will actually see the constellations. We'll learn something about the solar system. We will visit one or two planets in the solar system before we leave very far away from our region in the galaxy. We'll try to go even further, to go to maybe to see the other galaxies. Hopefully we will be able to see even to go to the edge of the universe. We will see something amazing there. Thank you very much for joining us today, and let's start our journey. This is the planetarium as you see it, and we can also see something else. Hopefully we will see that soon. You come to see our space exhibitions soon. Very unique, very special exhibits that actually are very educative materials and exhibits for astronomy and space sciences. A huge area full of exhibits about space and astronomy. We hope, inshallah, to be there very soon. Okay, let's start our journey to see the universe and the constellations from Sharjah here. Now, I will actually ask the system to go to the Earth, in particular, we'll go to Sharjah. We are in the outer space. We are in actually in an orbit around the Earth, but this is not the case all time. We would like to go to the Earth, where to Sharjah, to the UAE, to see how the constellations would look like from there. Please stay with me, and we are going to the Earth. We can see the stars, the sun, of course, our planet. And here is a special case when you are away from the atmosphere. You can see the stars, and our star, the sun, simultaneously. Why? Because of the absence of the atmosphere that actually inside it, as the case we are living now, that actually prevents the stars to appear because of the light, the huge light of this sun in within the atmosphere, the reflections inside it. Here, actually, we are looking at uh, the north direction now at this moment, and we can see one of the very famous constellations, which is very well known for most of people, and also very easy to distinguish for many people as well. When we look at the northern direction, sometimes it's very close to the horizon, north horizon, of course, and sometimes even it can be below the horizon. And it consists of 5 stars or 7 stars, as you see. It is a small part or some part of a bigger constellation called the Big Dipper, or the Ursa Major. This is called the Big Dipper. In Arabic, it's called the Banat Nash Al Kubra. That's the Arabic name in the Arabic heritage and mythology. Every single star has a name actually, and the names are of Arabic origin because actually of the big role the Arabs and Muslims in the golden age of Arabic Islamic civilization about 8 centuries ago or 10 centuries ago. Uh, and this is why we have more than 200 of stars having uh, names of Arabic origin. This is very well known. So let me now try with you to find one important star called the Northern Star or Polaris. That is very important when you get lost in the desert or in the sea or sail on the sea. So you need to find your directions. Now, very simple with GPS system, you'll be able to find that easy. But what about the ancient ages? Even 100 years ago, 50 years ago, it was not easy. You have to have your techniques to find the directions. One of those methods is to find the pole star Polaris. It was very easy for the ancients. Let me show you how that can be. Yes. So by making a line or drawing a line, sorry, between, just a minute. Yeah, this is the Big Dipper and the Little Dipper. And actually, what we can do is we can uh, just uh, draw a line between both. I'm just restarting the system of. Mhm. So, okay, so I will show you directly because that is not there from my mouse directly. If from Mirag, this star is called Mirag to Dubba. If you make a straight line, you will reach the star which is called Polaris. Polaris is a normal star actually in terms of brightness. It's not very bright star. It is normal. It is of the second rate in magnitude. There is rate 1 and magnitude 1 and 0 even, which is much brighter. So this water is very important. If we now run time forward, we will understand how to see how this star is always staying in its location in the north at about latitude about 24.5 degrees height, and you can see all stars are rotating around it. That actually is not real rotation. It's not real motion because the Earth is the one that rotates or spins around its axis, and the axis is going towards the star. This is why we see the whole sky is rotating. That is called an apparent motion for the stars. And the constellations, there are many constellations in the sky as you see now. We see here Drago, the dragon, we see Hercules, we see here Cygnus, and many other constellations. This is Picasso's, here is Andromeda, the princess. This is her mother, Cassiopeia. Now we can see the day time. And at this moment, would like to go to the outer space. So let's go to the outer space at this moment from the UAE to the outer space. I understand if the image is not smooth moving on the screen. This is because of the internet connection, not something else, not in our machines. It's very smooth here. When you come to the planetarium, hopefully very soon, that will be fantastic. You will see everything very smooth. This is our planet, the Earth. And now I would like to show you how the moon is orbiting the Earth before we see the why today or what tomorrow is the Eid not today. We see the orbits. I'd like just to focus on one orbit, the lunar orbit. This is the moon. You see the sun at the right direction. I'd like to rotate the sky to see the sun in front of us, to see the moment that we call, okay, the conjunction between the sun and the moon. Very important moment when we talk about the lunar month. Trying just to let the Earth, the Moon, and the Sun in one level. That's it. Forget this one. Actually, that is Venus was very enlarged for some reason, doesn't matter now. So you see now the Sun, the Moon, and the Earth are at the same line. That's the end of the month, and it is the same moment of the new lunar month, which is actually the Hijri month, the Islamic month. So this is actually the end of Ramadan, which took place yesterday, maybe close to this time, or about 9:30 last night, after the sunset, actually, not before. And it's very important to see the moon or the crescent before the sunset, before saying, okay, tomorrow is the new month of the Islamic month, Shawwal or whatever. So now we have, so of course, this is how the moon orbits the Earth. I will now focus on that orbit. Look again. I will fast, speed up to make it fast. You see the moon actually orbits the Earth. I can speed up, of course. That is Venus enlarged for some reason. Okay, let's now go to something else to see how and why the moon, actually the crescent, was not able to see seen yesterday with my colleague Muhammad Hani. Muhammad, are you there?
Yes, Assalamu alaikum.
Alaikum salam. I will stop my sharing. Please share your material.
Please.
And
Okay.
in 4 to 5 minutes, please, let us see why the moon was not able to be seen yesterday. And today there's a chance. Thank you very much.
Okay. Assalamu alaikum. Okay, it's clear now. Can everyone see my?
Yes.
Okay. Assalamu alaikum wa rahmatullah and Eid Mubarak for everyone. Okay, we'll start from where Mr. Marwan he stopped for this phase of the new moon. Of course, you know that Al-Quran, Allah subhanahu wa ta'ala, he said in Al-Quran, يسألونك عن الأهلة قل هي مواقيت للناس. That mean we have to cite the crescent moon to start Al-Eid or to start Ramadan. And this is the full complete cycle of the moon, 29.5 and half days, is starting by the new moon and waxing crescent, first quarter, waxing quarter, full moon, and etc. And we come back again to the new moon. This is what we name the moon monthly. But for Al-Hijri, for Hijri month, we have to start from the very thin crescent. This is Shahr al-Hijri, the al-Hijri month. We have to start from the very little thin crescent and to come again to the crescent again in the end of the month, of course. Here it is a little animation to show you how we can see the faces of the moon from the Earth. Look at here. Now we are on the Earth, and this is the new moon, and we start to see this is the full moon and the crescent and etc. This is because we are on the Earth. But if we are, for example, on the sun here, if we are on the sun, we cannot see anything. We cannot see any phases because there is no angle coming from the sun to the Earth. We are on the Earth, we see every day one angle, and the next day another angle. That's why we can see all the cycle of the moon. But if we are on the sun, as you can see, there is no phases. Imagine that we are in space, for example. Also, we cannot see all the phases of the moon. Just we see some phases but not others. It's very important to be on the Earth to see, as you see, all phases of the moon. Now, why yesterday? Why today we didn't begin Al-Eid? Because there is some condition to sight the Hilal. It must have at least 14 hours from the moment of the conjunction, which we see from with Mr. Marwan, and he must be 8 degrees, 8 degrees away from the sun, and it must stay on the horizon at least 20 minutes. That means this is three conditions, very important condition to sight the moon. Uh, Yesterday, 22 of the moon went down, as you can see here, at 6:48 p.m. and the sun is still here on the sky. That means the moon he was set down before the sun, and in this condition we cannot see the moon. And also, the new moon start at 9:38. That means we need more 2 hours to start the new moon. That's why yesterday it was impossible to see the moon because the moon was setting before the sun. On the other hand, today, as you can see, at 23, the sun is already set at 7 o'clock, but the moon is still now in the sky, and we can see the moon. It will still at least 20 minutes. In this condition, we can see the moon very easily, and inshallah, tomorrow will be the first day of Al-Eid. This is the first crescent. Now, Mr. Marwan, inshallah, he will show you on this. This is the Stellarium software. Here we can show you by, of course, by moving the time, how we can see this issue. Thank you very much. And كل عام وأنتم بخير. Happy.
Shukran, Mr. Hani, Barakallah Fik. Thank you very much for this short presentation. As we said, this is not actually presentations. This is just actually a show for the sky. So please now try to also with me to follow how the moon was seen yesterday before was being able to be not able to be seen yesterday after sunset. You see here, this is a very good program software. You can download it on your laptop or PC. Also, you can download it on your mobile phone, but the copy that comes on your PC or Mac, doesn't matter. That's excellent. It's free of charge and open source software, which make it very great one actually. So now that is time for today. I will go to yesterday. Now we can actually play with time as we want. So this is 23rd of May. I will go to yesterday. Just click here, or here this is up, this is down. Here is yesterday, Friday 22nd. And the time here you see is showing the sunset time. We can go back 1 hour back. You see actually the sun here. That is the west, and you can see the sun. If we zoom in here a little bit, we be able to see something here. I'm not sure if you can able to see it. That is the moon actually here. So you see the moon is sitting before the sun. That was yesterday, as Muhammad said. So if we push time forward here by minutes, you'll be able to see that the moon is sitting or sat yesterday about a long time before the sun. We can calculate that. We can count it very easy. But once the moon is sitting before the sun, that is not the case that we are looking for. The case we want is to see the moon is sitting after the sun. And then we talk about the following Islamic month. So this is not a sign of new month, because the moon itself, at the image we saw, was not even new moon, didn't actually reach the moment of the conjunction that some people call the new moon. Okay, so what will happen after one day? So I'll go to the same moment. You can see here the sun, the moon is here. Now I will push this to go 1 day forward, which is today after sunset. At the same time before sunset, doesn't matter. So look what will happen. The moon is here. So where it will be when I press here, look at the moon. Look. Okay, so jump from here to here. That's that means one thing. The moon is orbiting the Earth about 13. It moves in the sky or drifts in the sky about 13 degrees every day. So this is today. Still, the sun is there. So we have to push time forward here to see when the sun sets. So when the sun sets, the moon now is above the horizon. That means there is a chance to see it. But the sky has to be very clear, and so be easy to see it. And this is what really happened for some countries. But for us, we have already actually fasted the day 30 in fasting. This means automatically tomorrow is the first month of Shawwal, which is Al Eid. For some countries that actually fasted one day after us, that actually to them they have to see it or to follow the calculations or follow some other countries that manage to see it. There are many more than criteria. There are several criteria actually to see to talk about the lunar visibility and sighting. So this is not what we are intending to focus on today, but just this idea about the moon and the sighting. So this is a very beautiful program, as I said. So if we can push time forward, this is or backward. This is how to. This is time for now. We can go back to the moment. Yes, yeah. Now let's see how the moon and the sun setting, followed by Venus, Mercury these days, and the other constellations. We can see what constellations are. Though this is Gemini, you see the different constellations of the sky. This is Cancer, and you see here is Leo, and so on. We can zoom in and out to see the whole sky. This is a very good one, and I really recommend this software for everyone, for those who really love the sky and would like to learn more about the sky. Okay, so let's go back now. This is another day, the following day now. So let's go back to the universe. That is the Earth and Moon as we left them before we leave. And our plan is now to go even further. I would like to leave the Earth, to leave the Moon, to leave the solar system, maybe to see how big the universe is, how the galaxy, how big is the galaxy as well. Look, this is our solar system. You see here the planets. The last one here is Neptune, and we can see Uranus. This is Saturn. This is Jupiter. We can actually enlarge the size of them. I will try to make them larger so we'll be able to see them. Now I have able to see them from this different big scale, actually large scale of the solar system. So here we see Mercury, Venus, Earth, and Mars. So this is our solar system. Of course, all the planets orbit the sun anti-clockwise, actually. If we look from the northern point of the solar system, now we can see the constellations. These are the constellations. This is our solar system. If we are observing from a point away from the solar system, we still be able to see the constellations the way the ancients imagined them. So what about these lines? These lines are actually not real lines. These are the game that our ancestors did thousands of years to connect the stars together to give these patterns and that represent different mythologies. And now what you see is because we have already shifted very huge distance from the solar system, So now we see the constellations from different perspective. That means the constellations that we know are no longer there. We see something else. Look what will happen if we travel away from our solar system. To where? Ah, to a huge object in the universe. What is that object, and what is the contained in the center of this object? Something amazing. And this moment, I would like to invite my colleague Ahmed Salah ad-Din. Are you there, Ahmed?
Yes, yes, I'm here.
Ahmed and Muhammadani are astronomers and experts running the planetarium. Ahmed, what is this? What is this huge object we see, and what are these lines, and what is hidden at the middle of this object? Ahmed, please go.
Before we start, just like to know your volume has been low a little bit, your mic volume. So if you can adjust that higher, we could be able to hear you better. All right. So the questions are, what is that hidden massive object? Also those lines. So I think we have some answers in the chat. Someone, Samar Ihab Saadi Atwaqa, she's saying that it's a galaxy, and yes, of course, it's a galaxy. But the question is, what is at the center of the galaxy? If exactly that bulge you see at the center, what is it, and what are those lines you see on the right side of the center of the galaxy? Let's answer the question with the lines first. The lines are actually those constellations you actually saw during the nighttime Sharjah sky stargazing. These are the lines which form the constellations, the 88 constellations that we know. That means all the visible stars we have, most of the visible stars we have are only in this region. So the sun and the earth and the planets are at the center of the net of lines you see, but the constellations are all around it, and we can see it exactly how it is. So you can see the yellow lines, those are the zodiac constellations that we mentioned earlier. The red lines are the other constellations. And now we see the rest of the galaxy, and talk a few words about what is at the center of the galaxy. So, of course, before we start talking about the black hole, a big group of stars, who, as we know, billions together. So here we have our galaxy, the Milky Way, which has more than 200 billion stars, which is estimated by telescopes like, for example, the Hubble Space Telescope. It has been observing the sky for a long time, and we have been seeing all these images of the space of a deep sky and the Milky Way itself. So no one has gone outside the Milky Way and taken a picture. What we see right now is actually a model of what we observed. So the cameras from telescopes, they take images all over the space, all over the sky, and then they put together to form a 3D model using computer softwares. And that's how we figure out this shape of the galaxy. So from this theory, we realize that our Milky Way is actually a barred spiral galaxy. There are three more shapes of galaxies. We shall talk about the galaxies in someday when we have a lecture or when we have a show about galaxies. Now let's get back to the center of the galaxy. You see a big bulge of light there. So usually what people mistake it from the picture is that they think that big bulge of light is the black hole. But unfortunately, that's not correct, because the big bulge of light you see is actually the group or the big density of stars that can come together because of the immense gravity of the black hole. As you remember from I told you that the Milky Way has more than 200 billion stars, but most of the stars in the Milky Way are actually around the center of the galaxy. You can see the big grid there. The rest of the stars are scattered across. The young blue stars are at the edges. The middle-aged stars, like our sun, is at the average middle. And then we have the old stars, which are the red giants, and the rest of the old stars. They mostly gather across or gather around the supermassive black hole. Now, there are two types of black holes, mainly. The one type is called the supermassive black hole, which is usually found at the center of the galaxy, because a supermassive black hole is the only kind of black hole that can control all these massive stars in orbit. The other type of the black holes are called the stellar black holes, or they call mini black holes. Those are the black holes that you can find everywhere in the galaxy. It's not just one black hole in the center. Any star that's massive enough, more than around 13 to 20 times the mass of our sun, they can actually explode when they die, form a supernova, and then they convert into a black hole. The rest of the stars, when they die, they become neutron stars, or less massive stars like our sun. When they die, they become a dwarf or a white dwarf. That's the main death scenarios of stars. All right, so now what I'd like to talk to you about is the size of the black hole. How big do you think a black hole is? How many times do you think the size of our Earth or the size of our sun, or 10 times size of our sun? How many times do we think the black hole is big? It is really big. Thank you, Ihab, I suppose. So it is pretty big and it's super massive. So the size of the black hole is actually not as big as you think. The mass of the black hole is huge, but the size doesn't have to be huge along with mass. That's where we something called density. Jude Mahmood says 1,000 times more than the sun. Well, as size wise, nope, because massive black holes actually can be as small as a small city. That's a supermassive black hole. It can be smaller even. It can be even the size of a house. Some black holes can be the size of the house, but why is it so powerful in the form of gravity? Because it has so much mass in it. All the mass of the star has converged into one point inside the black hole, and it has become a very, very massive, highly dense object called a black hole. That's why we call it black hole. Now, the image you see in front of you, as we can see something called the accretion disk. That's the area around the black hole in which the disk starts pulling in the matter from the star next to it. As you can see, the white big object on the right side, it's actually a star. So black holes can actually feed on these stars. That's why they get more powerful. That's how they get more massive, because they keep on pulling in mass from the neighboring stars and neighboring objects. Nothing can escape the black hole's gravitational pull, especially if it's a supermassive black hole. Even light. Light, as we know, is the fastest element or the fastest object that we have observed. Light travels at the speed of 300,000 kilometers a second. That means it can go around this Earth 7 times in 1 second. That fast of an object or particle called photon cannot escape the gravitational pull of the black hole. Also, you can see the two jet streams from the edges of the black hole. These are highly charged particles coming out of the black hole from the extreme activity going around in that area. Also, there's a region in the black hole called the event horizon. The event horizon is the area that you can see around there. The event horizon is the point in space beyond which there is no return. So after that point, most scientists actually say that the rules of physics will change into different type of talks, because we can't really explain what happens in there, because it's really, really, the mass changes, the speed change, time change, so many things change in that kind of a situation. This image, as we see, is called the first image of a black hole. I should repeat myself again, image of a black hole, because most people, when they talk about this one, they call it picture. And when they say picture, we misunderstand that as a picture taken by a camera. A camera takes pictures. Our eyes can look at pictures. But this is actually an image. We call it image because it's actually a processed image taken from a lot and lot of observations done by radio telescopes across the world. There was a big network of radio telescopes kept across the world to actually find out this image, or the figure of this image. And then a big algorithm was formed by a computer, and then the image of the black hole was formed last year. This was the first time we looked directly at a black hole through images taken by radio telescopes. And this was at the galaxy M87. And this supermassive black holes are billions of times the mass of our sun. This is more massive, much more massive than the black hole in our galaxy. And also, the problem with our galaxy is that we cannot exactly see through a lot of dust in our galaxy, because the galaxy contains a lot of stars and interstellar dust. So many things come in the way. We don't really see the image of our own black hole. That's why we looked at M87, which was much, much more clearer, and we could see a better image. In this image, we can see the event horizon of how the area around the supermassive black hole is. That's the EH tree reconstruction. You can see down right how the image was formed, the simulation was formed. Even the Schwarzschild radius, which is the radius of a massive object, that's an equation done by Schwarzschild, or it could be measured by using these simulations. And now, quickly, we shall watch a short video about black holes. And this will summarize exactly what I told. And, this will be a nice uh, visual the representation of how we can watch black holes. So let's see. So I hope the video is visible now.
Yes, it is,
Yes,
but no sound.
the sound.
You need to share the computer sound.
This image represents the gravitational well that makes the black, any object that's massive enough can make in space time. So you can see those are the photons that's falling down, which is not exactly falling; it's getting pulled in by the black hole. And this image is again, this is a simulation of how a jet works through a black hole, and how an accretion disk works around a black hole is the same as we saw in in the presentation done by Mr. Marwan. We could see how the accretion works. So you can see the jet streams through the center of the area, and that's a representation of the galaxy. So these are artist impressions of these objects. This is not a real image, so don't think this is the real picture. These are the impressions of artists, because artists actually form these pictures to make it clearer for us. Another image of the center of the galaxy that we have here. So this is the image taken by deep sky object telescopes, and you can see how much objects and how many things are there in the middle of the black hole and us. So it's really hard to take an image of a black hole. Another simulation of the event horizon, beyond which things will start to wobble and change, and space time starts to warp around itself. So we can't really see a clear uh, impression of that. So these jets are really extremely powerful particles coming out of the black hole, which can be observed. And again, the black holes were first discovered in 1916, not discovered exactly, but talked about or predicted by the scientists there. This is Schwarzschild, who actually figured out a way or a formula to find the radius of these supermassive black holes, which convert itself into small objects, even smaller than Earth by many times. Accretion disk again, as we can see, this is the image that we saw earlier. We can see how a black hole can get more massive just by absorbing the mass from neighboring objects. So how did we see a black hole? We observed it by watching stars around it, how they move. That's how we predicted a motion or predicted something that really massive as a black hole. From 1916 it hasn't predicted, but observations started way later into the 20th century. That was the part of the video that I wanted to share with you guys. And now let's get back to the same.
Thank you, Ahmed. Thank you very
Mr.
much.
Marwan, I
And
think your volume of
now
the
the
voice is a little
connection is
low. So
again. Okay, I will.
yes,
Okay, so I hope you can hear me now.
yes, it's
Okay,
much better now. Yes, yes, it's
is
better.
that okay?
Yes,
Yes.
it's better now. Yes.
Okay, thank you very much for the good presentation about black holes. So, actually, now and very recently, the astronomers have actually discovered new, very close, the closest ever black hole to the Earth, which is estimated to about 1,000 to 1,100 light years from us. It's called, or the star is called HR 6819. You know, the stars actually usually are given names if they are so bright. If they are less bright, they are given either Roman letters or even numbers. So there are different catalogs for the star names. And this one actually is not only the closest one, because maybe it was the closest one to the Earth, which is 1,100 is not too close to be honest. It's not dangerous, because when we talk about dangerous one, it has to be maybe even closer than 100 to talk about if it is dangerous or not. When it is 1,000 light years away from us, which is about 330 parsecs, that is huge distance between us actually. And we don't think at any how it will be affected us or influencing the solar system from that distance. Uh, the good thing about this, or the special thing about this recently discovered black hole, is the stars are orbiting are visible. Believe or not, yes, you can see actually these stars as one star. Actually, when you look at them, sorry, when you look at them through telescope or even naked eye, you see one star. They are of magnitude about 5.5, 5.66, which is, to be honest, at the human eye limit or sight limit for humans, which means it's not easy to see it in the city. Forget it. You have to go very far away from the city. You have to go to the desert, okay? Number one. And secondly, to try to be in the south, maybe here can be seen from the UAE. If you go even more south towards countries more south, that's even better for you, because the star is very close to the horizon. If you go south, it means it will actually lift it up. So that's away. That will put it away from the dust and the humidity. That would be better for better seeing actually. So you'll be able to see it naked eye in good conditions. This is what I mean. But you're not going to see the black hole itself. What you'll see is these two stars as one star only. And what the astronomers found, they found these two stars are orbiting something missing, not there, not exist. I mean, visually. So, so what can be that thing that pulls and forces two huge stars to orbit it, and at very fast also speed? That something should be massive than the sun, massive than the sun, and invisible. This means one thing: it should be a black hole. This is why. But most of the other black holes actually have been discovered not by this way, but by detecting the X-ray coming beside the black hole because of attraction, the attraction from the black hole against the gas of the other stars, or swallowing the other stars. So this is actually a good example and very recently discovered. Let's go now to our planetarium, virtual planetarium. And if you remember, we are where? We are at the galaxy scale. We are looking at our Milky Way galaxy. And as Ahmed said, here at the center, there must be a huge black hole, very, very huge, which is estimated to about 4 million solar mass. Can you imagine? 4 million solar mass. The sun is about 330,000 bigger, times bigger than the mass of the Earth. I'm talking about the mass, not the size. Size even bigger, but the density of the sun is less. So actually, when you talk about millions of solar mass, can you imagine? Can you imagine that? What actually dominates the galaxy and the stars, which is far away, uh, really beside what we call the dark matter. So that's what dominate all stars and gas in the galaxy to rotate this way, not to actually scatter everywhere. But is the black hole is the only one, or Is our galaxy the only one in the space, in the universe? No. Let's go away from our galaxy. We are traveling away from it now. We are now at another limit. These are the Magellan, the large and small Magellan, small galaxies orbiting our galaxy. All of these are the local group of our galaxies, about 50, 54 small galaxies. Majority of them are small, but one of them is even larger than our galaxy, which is called the Andromeda one. And another one is also third one in size after the Andromeda and the Milky Way, uh, the Triangulum. You see here also other galaxies, millions of other galaxies. What you see is this, the galaxies are gathered together to make what we call clusters of galaxies. And the clusters are again clusters gathered together to make super clusters. And the super clusters again are gathered together to make very super clusters of the universe. And all of that actually is what we call the observable universe. And most of these galaxies have their own black holes in their center, if not all. So, but actually, the latest studies say most of the galaxies have very massive black holes, estimated to millions or maybe billions of solar mass. This is our universe. We actually even reach the edge of the universe. We don't think there is any edge, but this is what we, our telescopes, the orbital telescopes and the terrestrial telescopes or the Earth-based telescopes can see. That's the observable universe. And we can see beside the billions and maybe trillions of galaxies, we see here actually uh, some strange image, which is actually image of dark and bright areas here and there. That's what we call the microwave, the cosmic microwave background. That's actually can be explained something like the echo of the first lights and the energy that released after about 380,000 years from the moment of the Big Bang. If you know the Big Bang, if you don't know the Big Bang is actually the scientific point or the what we think that the universe started with. That is when the universe was too small and expanded and suddenly in a very quick time to be very huge, and that what we call the not the explosion but the expansion of the universe or the inflammation. And let's now go back to our region, the galaxy, before we to see or to answer your questions. Our Milky Way, we will step away from the black hole, just directly on our location. You remember these lines that represent the constellations, as we mentioned, and at this moment, we still cannot see our constellations, but as we come closer to our point where the ancestors actually imagined these structures or these figures, that is our location. Actually, if we go away from our place, from the galaxy, then the shapes will be completely changed because it is perspective from our location since we started to look up and see the stars. thousands of years ago. This is our solar system. Would like now to go directly to the Earth. Let's stop here. Let's just stay here. Let's stay here in the outer space, and let's see. I think this is the end of the show for today. Every Friday and Saturday we have the same, actually, Friday in Arabic and Saturday in English. So now let's see, or let's answer any questions or comments. Thank you very much, ladies and gentlemen, boys and girls. I know there are many people are there. So please feel free to ask. You can raise hands up and just ask. Ahmed, please, if you can take care about the
Yes. Someone
questions.
has a question, please do raise hand. I will unmute you so you can ask the question and then we can discuss. I think we have a hand from anybody? Summer? Summer? Okay. Mr. Marwan, can you reduce the volume of the music, please?
Yes.
Yes. تفضلي سمر.
You said يعني every Saturday and Friday we will have the same meeting.
Yes, Ahmed, please go ahead.
We have every day, Friday and Saturday, we have a show in Ramadan. The timing was from 10 to 11. But inshallah, after Ramadan, after Eid, we'll be having the shows from 9 to 10 o'clock in the evening.
So from ever, so like after Eid maybe يوم الثلاثاء يعني can I join at 9?
Yom al is Tuesday, so Tuesday currently we don't have a schedule for Tuesday. It's gonna be Friday, Saturday. But inshallah, if we develop the shows to weekdays, we shall make an announcement and you can join on the weekdays. But for now, it's only Friday.
Yes. Actually, there is a plan to increase the number, but once to see more people are interested, so then we will directly, inshallah, make maybe every day. We don't know. But
So
we
some
see
are
just
inform your friends and let them join.
yes,
Yeah.
yes.
So and every Friday and Saturday.
Yes, that is correct.
Thank you very much. I had so fun in this meeting. Thank you very much.
Thank you so much.
Thank you very much, Samar. Yes,
Okay, we have a question from Mina Muhammad Adnan. Mina, تفضلي.
So like at Friday and Saturday 10 p.m. we will have like a meeting.
It's going to be just like this. We have a show with the stellarium, the planetarium show with the constellations and the topic we'll talk about. So it's going to be like this, but with a different topic, inshallah. Every Friday and Saturday.
Okay, thank you.
Okay. Next we have Jude Mahmoud. Jude?
Yes.
Yes.
My question is: the black holes are close to which specific planet?
Well, we don't really have a close black hole to us, generally speaking. The closest black hole that we have discovered is about 1,600 light years away, which is a small black hole. It's not even close to the sun, not close to the to Jupiter, to Saturn, no, none planets, because our solar system is very small and it's compared to the big space. So 1,600 light years actually is a very, very far distance. So it's not close to us as a whole.
So it's in a galaxy, but not in a specific place.
It is in a specific place inside the galaxy, yes, but not anywhere close to us, the Earth, or the planets, or the solar system.
Thank you.
Welcome. We have Yazan Deeb next with a question. تفضل يزن.
السلام عليكم.
السلام ورحمة الله.
أنا يزن من أصحاب الهمم.
يا أهلا يا يزن. أهلا بك وجميع أصحاب الهمم.
هل هذا العرض اللي عم تعرضوه هلا يعني على الكواكب يعني؟
نعم أكيد نحن بنعرض عن الكواكب وعن النجوم، عن المجرات وعن كوكبنا الأرض والقمر طبعا. هذه يعني الفلك، هذه كله اسمه علم الفلك. فنحن كل ما هو فوق في الكون نتكلم عنه. هذا هو اختصاص الفلكيين، الحديث عن ما في السماء من أجرام سماوية، الشمس والقمر والكواكب والنجوم والمجرات. واليوم خصصنا حديث عن الثقوب السوداء، وهي نجوم ميتة كما ذكر أخي أحمد.
آه.
نعم.
هو العرض بس هو العرض بس اليوم ولا؟
لا، العرض كل جمعة إن شاء الله الساعة بعد رمضان الآن الساعة 8، مش الساعة 10، 8 مساء كل جمعة، ويوم سبت، جمعة بالعربي والسبت بالإنجليزي مثل اليوم. الآن الأسبوع القادم من
الجمعة
8 ل
بالعربي.
10، من 8 ل 9، وليس من 10 ل 11 إن شاء الله بعد
اه
رمضان.
اوكي
نعم.
مان، شكرا شكرا
أهلا وسهلا، أتمنى تكونوا استمتعتم معنا.
شكرا.
Yes, please. Any
شكرا.
other
شكرا
please.
يا any other questions؟ أي سؤال آخر؟
Okay, if that is everything,
Yes.
Fatima has something to say.
فاطمة
Six, oh, grade 6, Fatima. Okay, Fatima, thank you very much for joining us. She is only grade 6,
ما
and
شاء الله.
in particular B, not A, which is beautiful, beautiful letter, yes. And she is
has a
interested. Yes, she is interested in astronomy and reading maybe. And the evidence is what is being with us tonight. Thank you, Fatima. Thank you very much. Please keep on. Please read more. We hope we see you and everyone at the planetarium soon after, inshallah, this situation finished, inshallah, and recovered. Okay, and Muhammad is there also?
Yes.
Yeah, Sahar as well. Okay, so I will show you something before we leave. Can you see here this constellation, which is called Scorpius, the Scorpion, actually this one here, and here is Sagittarius. Okay, forget our solar system. This is not what I want to talk about. I will just go away from it. Doesn't matter. Here, this small constellation called Telescopium. This is actually uh, recently means about 300 years ago. But here, somewhere here is where the black hole, the closest black hole that I mentioned was discovered. The one that is about 1,100 light years away from us is almost here. One important black hole as well, I will try to mention to point to one of the very, very early discovered black holes, which is Cygnus. Yes, this is Cygnus X here, in this place here, almost here. It was actually discovered in 1965, if I'm not mistaken, but the 60s last century. So that was the very first black hole detected by X-ray, I think. So good idea to, when we look up the sky, and just to remember it could be a black hole there or there, but be just don't be worried, because they are very far from us, very, very far from us. Any other questions before we leave?
Before we leave, I'd like to confirm that the shows we have Friday is Arabic shows, and Saturday is English, just to
Yes.
confirm the language and the day.
Yes, and time again, as you mentioned. So after Ramadan, the shows will be from 8 to 9 o'clock p.m. From
8
8
to 9.
o'clock, 8 p.m. to 9 p.m., not 10 to 11 like Ramadan now. And this is the last of Ramadan. And let me say Eid Mubarak for everyone. And I would like to see you again, inshallah, next week, Friday in Arabic, 8 p.m., and Saturday in English, 8 p.m. again, to see different topics, inshallah. Thank you, and Eid Mubarak. Assalamu alaikum.
كل عام وانتم بخير يا جماعة.